All right, so before we do any sort of material, I want to go over the entire syllabus, and it's actually quite long. So, yeah, we just have to go over it and make sure everyone's on the same page. Okay, so first of all, this is College Physics 1, right? Everyone's in the right class because every once in a while some people wind up in the wrong class. So we meet 7:10 to 9 p.m. On Tuesdays and Thursdays. All the tests are in this room. Nothing is outside of this room, including the final. So it's an hour and 50 minutes long, but around 8 o'clock we take a 10-minute break, give or take a few minutes, around 8. So you will have a break every class, 10 minutes. My name is Dr. Gross, in case you don't know. My office, in case you want to come to office hours or find me, is in the building behind here. It's known as the Science Building. It's the SC Building, 118 on the first floor, which is down the hall from the physics office, which is SC 108. That's the main physics office. This is where the mailboxes are for both me and the lab TAs. So you don't typically need to hand anything, put anything in my mailbox, but you sometimes have to put your lab reports in the mailboxes of your TA. All the mailboxes are in that room, which is the main physics office, SC 108. And the lab does not start this week, it starts next week, in case you're wondering. So there's no labs this week. I don't have a phone, but of course I have an email address, and my email address is rgross1@fau.edu. Right? So that's what you need to, how you can contact me. I should mention that this syllabus will be posted on Canvas, so you don't have to really write this stuff down. After this class, so like later on tonight, I'm going to post all this stuff on Canvas. Okay, so moving on. So my office hours are basically Tuesdays and Thursdays before class from 1 to 3, and from 2 to 4 on Tuesdays and Thursdays, and then 1:30 to 2:30 on Wednesdays. So if you want to have any questions or need extra help, those are the days to come by my office, or by appointment. If you can't make it any of those days, you can either email me or see me probably after class or before class, and we can try to set up a time outside of these times. Okay, so I'll mention in more detail what the review session is, but there's a review session that I hold on Wednesdays. It's Wednesdays from 3 to 4 in the same building as my office, which is the building behind here, the SC building. 319A, so it's not on the first floor, it's on the third floor. There are 4 floors in that building, so it's on the third floor, and it's 319A. It's confusing because there's 319s for some reason in that building. This one's 319A. So anyway, it's a smaller classroom, and that's where we hold review sessions. I'll talk more about the review sessions in a minute. So I didn't know the SI sessions before a little while ago, so I haven't put that in there yet, but I'll put it on, I'll put it in the syllabus before I upload it to Campus. I will eventually have a TA for tutoring, but I don't know who it is because we still don't know. I still at this point don't know who I have as TAs. But when I know, I'll make an announcement on Canvas, and I'll let you know. So everything that we do is going to revolve around Canvas. So basically everything related to this course will be on Canvas. So you have to make sure that you're on Canvas. I activated Canvas this afternoon. I did not put anything on there yet. It'll be on there after class today. But so you need to make sure tonight that you're on Canvas. If you're not, you should have automatically registered, but if you're not, you need to email me and then let me know, and then I can add you to Canvas myself. So that's important that you're on Canvas because, like I said, everything that we do in the course will be on Canvas. So there is no book. There's many reasons why I don't use a book, but let's just say I don't use a book. So instead of a book, I post PowerPoints, everything that I write on this tablet, turn into a PDF, post it online. Actually, everything that you see on the screen and you hear me saying is also made into a video, which will be posted on YouTube, which would be available on Canvas as well. So all the lectures are on YouTube and on Canvas. So that's the book. the notes, the PowerPoint, the videos. Some people don't like that, and some people maybe like a different explanation on something or additional problems. So if you want a book, the physics that we do in this class is the physics that's been done for 200 plus years. So it hasn't changed really at all, the stuff that we're doing in this class in 200 years. So basically any old book that you can find that's algebra-based physics book works, right? So it doesn't have to be a new book. It can be an old book. Or you can get this thing called the Shams Outline, which is like $20 on Amazon, or less than $20 on Amazon. And it's basically just a little, not a little, it's this big, maybe 300-400 pages, paperback book that has basically a bunch of worked out examples of physics problems in it, right? Step by step. So this is a good thing to get regardless of if you need extra help. It's good to practice some extra problems too. And it's cheap. It's less than 20 bucks. Right? So like I said, if you want a book, just buy any book. Otherwise, just use my notes and the PowerPoint and the videos, right? Okay. Anyone have any questions on that? All right, so some of these things I need on the syllabus for accreditation purposes. So I'm just going to skip by these things kind of quick. For instance, the prereqs, I think everyone knows what the prereqs are. But the important thing to know is there's two prereqs, math prereqs, which is methods of calc and trig. The methods of calc has no trig. We don't do trig in this course. I mean, we don't do calculus in this course, I should say. We do trig in this course. So are there any people in here who have never had trig ever? Yeah, okay. So that's a minor problem because we use trig quite often. But what we're going to do today is a little bit of trig, and hopefully it's enough for the people who haven't had trig to do physics, right? But that prereq needs to be changed, but they don't want to change it for some reason. I don't know why. FAU is kind of crazy like that sometimes. But yeah, methods of calc shouldn't even be a prereq. It should be trig, just trig. Anyway, it doesn't matter. We'll go over some trig, and hopefully everyone gets it before we need to start using it in the context of physics. So the objectives are basically, what any first semester physics course is. Anywhere you go, the first semester physics is always the same thing. You basically do something called kinematics, which we'll start doing next week, or actually Thursday probably. And then we do projectile motion and Newton's laws and learn what a force is and what work is and what energy is and what momentum is, and rotational motion and torque and all those things. You'll see what we do as we go. If you have some sort of disability, either a physical disability or a learning disability, you need to contact the Student Accessibility Services Office on campus and request accommodations through them. If you already haven't done so, you need to do it soon because it takes a while to go through. So that's just if you have some sort of disability. The information is here. All right, so let's talk about, let me move this down a page so it's easier to see. Okay, so let's talk about how you get graded in this course. So it's basically on three things. So technically it's four things, but let's just worry about three things for now. So basically you graded on homework, which is assigned often, quizzes, which are given often, and tests, which are every once in a while. So in a final, but don't worry about the final just yet. I'll mention more about the final later. Well, let me just say right now, so it's not as confusing. It's optional, the final, right? So for most people, the final doesn't factor into their grade. The main thing that factors into your grade are homework, quizzes, and tests. So the way it works is if your homework average is better or greater than your test average, I kind of try to help you out and make your homework count for more than it would otherwise count for. And your homework would count for 20%, and your test would count for 50% on an individual basis, not for the whole class, right? Individually, per student. And then if your test average is better than your homework average, then your homework only counts for 10%, and your test would then count for 60%, but that's better because you do better on your test and homework, then you want your test to count more than your homework. Right? And then the quizzes are fixed at 15. They don't change, right? It's always 15% for everyone. However, the lowest two homeworks are dropped over the course of the semester, and the lowest two quizzes are dropped over the course of the semester. Don't drop any tests. All your tests count. But your homeworks and quizzes are dropped, right? The lowest two, including quizzes or homeworks that you missed that count as zeros, right? They could be dropped. All right, so is everyone clear on the weighting? All right, so let me just say that on Canvas, after you submit your homework and quizzes, you'll see your homework and quiz scores, but after every test, I'll put your averages on there, right? So if you go on Canvas and you look at your grades, it calculates something called, I forget what it's called, like total, something called total. That thing has nothing to do with your average whatsoever, right? So don't ever look at that, just ignore it, right? This thing called total. So after every test, I'll put what your homework average is on Canvas, I'll put what your quiz average is, what your test average is, and what I call your overall average is, which is factoring all these percentages into your grade, right? So after every test, you'll know what your overall average is, right? And that's the thing to pay attention to. All right, does that make sense? Okay, don't look at the total thing, right? It doesn't make any sense, and it has nothing to do with your grade. All right, so this is the tentative exam schedule, right? So basically nothing happens in this course to throw off our schedule. This is when a test will be. But every once in a while something happens, like you have a hurricane, which you had last year, or sometimes, I mean, it happens every once in a while. Sometimes like the computer doesn't work or something and we have class one day because the computer's not working. In that case, I'll, of course, change the test schedule. But if nothing happens over the course of the semester to change our schedule, then this is the day. These are the dates of the test, right? So September 13th, October 11th, November 1st. These are Thursdays, by the way. This last one is the Tuesday before Thanksgiving, right? So you take it, and then you go Thanksgiving. And then you're done, actually, if most people, if you don't have to take the final, you're done after test 4, which is November 20th, right? But if you need to take the final, it's December 11th from 4 to 6:30 here, right? So the makeup, it's just on the syllabus, but it's a typical makeup policy, right? So basically, if you have a legitimate excuse for missing a test, then you can take a makeup. You have to give me notice within a couple of days, though. You can't email me 3 weeks after test 1, say that you missed test 1 and you want to retake test 1. You got to give me, reasonable notice within a couple of days. And then, if you have documentation, then you can get a makeup, and the makeup is different than the test that was given in class. It's not the same test. Yeah.
So are the exams hand-drawn or is it blocked?
I'll go through that. We'll get to that. Yeah. Yeah.
How much documentation do you need for our makeup? Like
Something reasonable, not really that
Okay.
strict about it, but something
Yeah.
reasonable. Yeah. I don't have a gigantically high bar, but it has to make sense. So anyway, the other thing that comes up is incomplete. So some people don't understand incompletes. Incompletes are supposedly for when someone is doing well in the course, like as a B or an A, and then say you get pneumonia and you have to go to the hospital for like 3 weeks and you can't do your work or take your test. Then you can get an incomplete. You can make up the work that you missed, and that's how incomplete works. It doesn't work if you're failing the course and you just want to get an incomplete so you can retake it. That doesn't work, right? If you're failing, you just drop. The drop date is November, right? It's way out there. So you're not doing well and you just drop. Don't ask for an incomplete. Okay. So here's where we talk about the study sessions, the tutoring. So like I said, eventually we'll have a TA which will do tutoring, which will provide tutoring for you. But I also have this review session, which is once again on Wednesdays from 3 to 4 or later than 4, depending on how quick we go. So in these review sessions run by me, I will basically, it starts next Wednesday, by the way, not this Wednesday, next Wednesday, not tomorrow, a week from tomorrow. Did I mention the lab start next week? I don't remember. Okay. So starting next week is the first review session. And during the review sessions, basically I'll supposed to be like sort of an informal session where you ask me questions, and most of the time it boils down to me answering homework questions. So almost every single review session, I just basically go over homework questions and show you how to do the homework, basically. Not every step. Right? You have to think a little bit, fill in the details, but majority of the homework, I'll show you how to do. You just have to do a little bit here and there. And then on test weeks, the review session will revolve around the test, right? Which would be study, questions related to the test. All right, so does that make sense? Okay. This is something we need for the accreditation, the topical outline, which is the tentative sort of outline of what we're doing, but don't worry about it because I don't know. It depends how fast we go, how slow we go. So I just need there we go, skip through that. Okay, so let's go to the homework assignment. So basically, the way I do assignments and quizzes, homeworks and quizzes, is a little bit strange. Some people don't like it, I understand, but it's the way I do it, and you just got to get used to it. It's not that bad. So after every week, you have a homework, right? Basically every week. Except the week before test. You don't have homework the week before test. But every week there isn't a test, you have a homework, basically. Okay, so the homework is based on what you do that week. I don't like giving homework ahead of time because you don't know what the homework questions are. You haven't seen the material yet. So let's take this week as an example, right? So we have a class, part of the class, after knowing the syllabus today. We have a full class on Thursday. And then after that, I'm going to give you a homework based on what we do today and Thursday, the first two lectures. And it'll be assigned on Friday. So this Friday, you'll have your first homework. And you have a week to do it, so it'll be due next Friday. And like I said, it's just based on this material. So it's a little bit weird because people don't like it sometimes because next week we'll do new material. Right? We're not going to be stuck doing the material we do this week for the rest of the semester. So we'll do new material next week, but you're working on the homework that's related to this week, next week, right? So it's a little bit weird, but that's how I do things. You just get used to it after a couple weeks. So it's on Canvas, and you have 3 attempts to do each homework assignment. So they're certain problems, and basically you work out the problems, you stick in your answer, and then when you're done with doing one attempt, you hit submit, and it tells you what answers you got right and what answers you got wrong. Then it tells you the correct answers and the incorrect, the correct answers for the ones you got right or wrong. So the next attempt is the same problems with different numbers. So it's the same problem, different numbers. So basically, if you got a problem wrong on the first attempt, you could look at the correct answer and then see what you did wrong from the first attempt, and then use that approach to correct it for the second attempt, right? And then there's a third attempt if you don't get it right after the second attempt. So you have 3 attempts. Unfortunately, you have to do all the homework, all the questions for each attempt. You can't just do the one you got wrong again. It doesn't work like that for Canvas. It'd be good if it did work like that, but it doesn't work like that, right? So the point is, after the third attempt, you should get a perfect score. That's the whole point, right? And that would help with your average, right, overall. And I should say right now that all the assignments, the homework, the quizzes, and the tests, everything that your grade is based on, is more than 100 points. And the extra points are like extra credit, right? So the homework's not 100 points, it's like 105 points. It could be even more, it could be like 110 points. So that's extra credit, right? Which is sort of built into the class. So the homework is kind of hard. I do it on purpose. The reason is because if you can do the homework, you can do just about anything in the class pretty easily, right? So you work on the homework, if you understand the homework, you don't have to study much for the tests. And the other thing, which I'm going to go over, quizzes. The quizzes will be easier as well, right? That's the whole point of the homework. The homework should be the hardest thing, and then the quizzes and tests by far easier than the homework. Okay. So, but the point is, if you can get help on the homework. You can work with your classmates on the homework. You can go see my TAs when I have them for the homework. I'm going to go over on the review session. You can come to office hours. You can go to the SI. There's all sorts of ways to get help with the homework so that everyone gets perfect score. And you have a week to work on it too, right? Okay, so let's go on to quizzes. So let's use this week as an example. So you have a couple lectures this week. You have a homework on Friday. Next Friday, the homework's due. And after the homework's due, I'm going to post a solution to the homework on Canvas. This is both the notes worked out, step-by-step notes, and also a video explaining how to do each problem. That's on Canvas, after the homework's due, obviously. So the point is, after the homework's due, if you still don't understand anything, you can look at the homework solution, and then hopefully you understand what's going on after you see the homework solution. And then after I post the homework solution, the next day there'll be a quiz. Now that quiz will be based on the previous week's homework. So next Friday, homework 1 will be due. And next Saturday, not this Saturday, next Saturday, you have your first quiz, which will be based on what you did in homework 1 and what you did the first week of class, right? Not on the second week. So everything's kind of delayed a week, which some people don't like. But most people don't have a problem with it. A few people do. But you get used to it after a while, right? Okay. So the quizzes are meant to be mini tests. Okay, so you only have one attempt at them because you only have one attempt on a test. It's also timed. Tests are timed, right? You don't have an infinite amount of time to take a test. You have a certain amount of time to take a test. So you have to know how to sort of answer problems sort of quickly. So you should basically approach the quiz like a test and sort of study for it like a test and see how well you do the problems. The quizzes are basically mini tests to test what you know and what you don't know before you take the test, right? It's better to see what you know and don't know before you take the test than after you take the test, right? That's what quizzes are. Okay, so quizzes are timed. They're one attempt only. You have a few days to take it. It'll be assigned on Saturday, due Tuesday night most of the time. So you can take it anytime from Saturday to Tuesday night, but it's only one attempt and it's timed. And when you submit it, you do not see, you see your score, but you do not see which answers you got right or wrong until after it's due. Then after it's due, you can go back in and see what you got right and wrong, what the correct answers are. Also, after the quiz is due, I'm going to post a solution for the quiz as well, right? The notes and the video explaining how to do the quiz. The quizzes are a lot easier than the homework, though. They're little, tiny questions. The homeworks are long. Quizzes are short little questions, right? Just to see whether you understand the basic stuff, right? For the test. All right, so does that make sense? Okay. And once again, the quizzes are more than 100 points too. Right? Everything's more than 100 points. All right. So this doesn't happen often with Canvas. It used to happen with Blackboard more often than Canvas. We used to use Blackboard a couple of years ago. But it did happen with Canvas, I think, last year. So every once in a blue moon, Canvas doesn't record one of your attempts, either homework or quiz. So every time you submit an attempt, you either want to print out a result of your attempt or use a PDF writer to save a copy to your computer, just in case it doesn't record. So that if it doesn't record, you can give me your printout or email me your PDF, and I could, enter in your grade manually. Else it's 0. You can just tell me, oh, I took it, and it didn't record. I mean, that doesn't almost ever happen. So you have to have proof of that, right? So you need to print out your attempt or have some record of your attempt. All right, so the other thing is that I seldom ever extend due dates. Like if Canvas went down, then I would extend the due date, but Canvas isn't going to go down because it's tied to the Amazon web server. So the only way Canvas goes down is if Amazon goes down. I don't remember Amazon almost ever going down. So I don't extend due dates or any, because the reason why I don't do that is because people have their own schedules and work and everything. And they plan to take the quizzes at a certain time. If I move those times around, it screws everyone else up, right? So I don't change due dates for anything. And the other thing I should say for the quiz, all right, so the quiz is one attempt. That's it. So if you take the quiz and your internet goes out, which happens every once in a while, or your power goes out, then you're going to get a 0 for the quiz because it kicks you out and you get a 0. So if that happens, you can email me and I can reset it for you. But the whole process takes a while to happen. You have to email me. I have to get the email. I have to reset it. I have to email you back. Then you have to get my email. Then you have to retake it, right? So the whole thing takes a while. So you can't do the quiz at the last minute. I mean, you can. But I'm just saying, if anything happens while you're taking the quiz at the last minute, I'm not going to be able to reset it in time. It'll be a 0. Right? So unless you want to get a 0, you want to take the quiz quite a while ahead of time. At least I say 12 hours, just so that the whole process can work. So even though it might be due Tuesday night, you should try to take it Tuesday morning just in case something happens, right? But if you want, you can take it at the last minute, just so if anything happens, you're not going to get it reset. All right. And quizzes should be individual things. They're meant as mini tests. They're not meant as group projects, right? So do not work together with someone on a quiz. It's pretty hard to figure that out. But if I somehow figure that out, it's bad. It's technically cheating, right? Homeworks, it's fine. I don't care. Homeworks, you can work on with whoever you want to work on. But quizzes, no. Quizzes have to be on your own, right? Okay. Okay, so this is how tests work. Someone asked me tests, right? Okay. So tests will be a mix of multiple choice and partial credit written problems. So there's about 15, well, not about, there probably will be 15 multiple choice questions. And the multiple choice questions, I'll go over this again before the first test to remind you. But the multiple choice questions would be calculations, definitions, and also some conceptual questions on there as well for the multiple choice. And of course, the written problems will just be calculations or the partial credit for it. So the multiple choice, of course, is right or wrong. You don't get partial credit for it. But the written problems will be partial credit. And there'll be 2 written questions per test. But each written problem has multiple parts, like A, B, and C. And usually, like B is related to A. Like you get the answer from A, and you use that for B, and then you use that for C. So they're not from scratch, right? If you get one, then you get all the rest of them fairly straightforward. So that's how the tests work. Now, for the test, you have to bring at least a pen, or a pen and a pencil, but at least a pen, because the answers for the multiple choice have to be done in pen. And also, your final answer for the written part has to be in pen. So you can do the steps in pencil, like all your work in pencil, but the final answer has to be written in pen. Like you have to write in pen. X equals 3, written in pen. Right? Okay, so you need a pen, not just a pencil, a pen. You also need to bring a calculator. It doesn't matter what calculator, any calculator. It could be a fancy $150 graphing calculator or a $10 scientific calculator. It doesn't matter as long as you know how to use it. It's an important thing, know how to use it for the test. Some people don't know how to use their calculator when the test comes around. So you have to make sure you know how to use your calculator for the test. You also have to bring an ID for the test. So you know it's you taking the test. You can hire someone to take the test for you. And the other thing is that I will provide an answer key. So you don't have to bring a Scantron. And the last, an equation sheet too. So the major equations that we talk about in class will be on the test. I'll post the equation sheet ahead of time on Canvas, usually the week before the test, so you know what it looks like before you see it on the test. But that equation sheet that I post on Canvas will be printed out and stapled to the back of your test. And I'll provide scrap paper too for the test. Okay? All right, so does that make sense? Okay. Yeah, this is weird, but it works. Yeah.
How long is each test?
Hour and 40 minutes. Not quite an hour and 50. Technically, this class is an hour and 40 minutes. You get a 10-minute break. So anyway, it's an hour and 40 minutes each test. Okay, so yeah, so I just felt the need to put this on my syllabus at one point because it got kind of annoying. So you know, in a typical semester, no one comes to see me at all during the semester, almost no one. During office hours, any time. And then what happens at the end of the semester, around Thanksgiving, I get 30, 40 students come to me discussing what they need to get, an A or something, and they have a D, after 3 tests. It's impossible to change your grade that much in that shorter time. So, it's a waste of time for both people, the student and me. You're just wasting time talking about things that are impossible. So the point is, if you have a question about your grade, come see me before 3/4 of the way through the semester, which is about November 9th, right? So if you, don't come and see me about your grade after November 9th, right, is the main point. If you want to change your grade by a lot, if you want to discuss how you can get an A and you have an A minus, okay, that's fine. But if you're, you have an F and you want to discuss how you get a C, you can't, it's impossible, right, after some point, right, which is usually about 3/4 way through the semester, right, and you're just wasting a lot, both of our time. So I put this on the syllabus now. Okay, so cheating, don't cheat. So I'll have proctors during the tests and watching for people cheating. But cheating is actually sort of more rigorous, more strict here than I thought it was. So does anyone know how the actual cheating policy works? Does anyone bother to look at it? Because I think most people should know how it works. So if you get caught cheating for any reason, either cheating during a test, cheating anyway, cheating, sharing quiz questions, working on quizzes together, anything. We file a petition, it goes through, and basically, no matter what happens, you get a mark on your transcript that you were cheating, right? If we can document it somehow. And it's up to you to appeal it, or go through there's a class here, which I didn't even know about, academic integrity. So if you do that and appeal it, or go through this course that you get your mark removed, but even if you get your mark removed and you cheat again, just twice, not 3, 4, 5 times, twice, and it goes through the process, you get expelled from the school, right? And that mark goes on your transcript, never to be erased. And if you have that mark on your transcript, not many schools will let you in if you were expelled for cheating, right? It's only 2 times, not 3, 4, 5 times, twice, right? So don't cheat, right? So don't cheat during a test, don't cheat otherwise. You can read it. You can read it here. There's a link here when I posted on Canvas. Actually, it's here. It's written here. So it says right here, in the case of repeat offense, either invitation violation from the first has been expunged from the student will be expelled from the university, right? Just 2 cases, right? Okay. So let me just say something about a couple more things, and then I'm done with this syllabus. It's kind of long. So one thing is the final. So the final is optional, right? So basically the idea is you try to get an A on the test, right? Then you're done. After the 4th test, you're done, right? Which is actually before Thanksgiving, technically, right? You take the test before Thanksgiving, which is good because then you can study for other tests and not worry about this class anymore. If you're not happy with your grade after the 4th test, then you can take the final. And the final can either really help your grade or really hurt your grade. And it usually really hurts people's grade. So every once in a while, it helps someone. But you do have the option to take it, is what I'm trying to say. Now, the final is hard. It's harder than a typical test. So if you can't do the regular test, the chances of you somehow doing well in the final are pretty remote. But if this were to happen, there are some benefits of taking the final. For instance, if you were to get an A in the final, that's what an A is, by the way. I don't know where my cursor just went. If you get an A in the final, you get an A in the class, no matter what happens. It doesn't matter what your grade is. You get a 0. Somehow get an A in the final, and then you get an A in the class, because the final's hard, and it's basically cumulative and hard. So basically, if you can do the questions on the final, then you know material well enough to get an A. But that's why it's hard, because if you get an A in the final, you get an A in the class, right? So, but the point is the whole thing's optional, so you don't have to take it. And the whole point is to try to get an A before the final, and then you don't have to even worry about it, right? So if you want to know how the final works, you can read this whole section. I'm not going to go through it now. I'll go through it at the end of the semester for those who need to take the final, right? Or you can read it on your own here. It's this whole thing. It's complicated. But don't worry about it, right? That's the point. Okay, so let me go through this quick, and then I'll say one more thing. This is my grading scale. So the overall average that I post after every exam, that's what you want to look at, and this is how you convert your number grade that I post on Canvas to an actual letter grade. So the main thing is you want to get above a 91.5. That's an A, but that's not that hard because everything's more than 100 points anyhow. It's not really 91.5. You need something like an 88 or 87 when you scale it up, when you factor in all the extra credit to get an A. The thing you want to avoid for most people is less than a C, which is a 72.5. Okay, so that didn't, let me move that down so you can see it all. Yeah, so a C is a 72.5, right? So that's the thing you want to avoid. And like I said, there's extra credit built in everything. I don't really scale. I scale by maybe, I'm not really that much of a jerk. If you have like a 79.4, I'll probably give you the 79.5. Other than that, I'm not going to do any scale, right? Your rate is your rate at the end of the semester. All right. Okay, so there's one more thing I want to say is attendance and coming to class, right? So basically, like I said, every lecture, I record the lecture and post it on YouTube, right? So the whole lecture is on YouTube. And some people don't like coming to class, and they actually prefer watching it on YouTube because you can go at your own pace. You can pause the lecture. You can fast forward the lecture if you're getting bored and you want to go to the next thing. So I don't take attendance, and I don't care. I care, but if you prefer to not come and watch lectures online, it's fine. We got to do one of the two things. You can't just not come and not watch things online because I say things like I remind you when the next test is, usually every class, and I get emails. When's the next test? When's the next test? One, it's on the syllabus. Two, I say at the beginning of every single class. I don't like repeating myself a million times. If I say when the next test is at the start of every single class, for 3 or 4 classes, you gotta watch the videos or come to class and pay attention, know basic information like that. Don't respond to emails asking when the next test is or whatever, right? Everyone get it? The other thing is, one reason why I don't take attendance is because I don't like forcing people to be here if they don't want to be here. So I'd rather have a bunch of people paying attention than force people to be here who aren't going to pay attention. So if you're going to come to class, I ask that you pay attention for most of the class. I realize attention spans are pretty short these days. But for instance, if you're tired and you're going to sleep the whole class, that doesn't make any sense to me because the whole thing's on YouTube. Why would you come and sleep during class? You can just stay home and sleep. Or if you're going to type on your computer all day, all class, it doesn't make any sense either because you could just go to the library and type or go to Starbucks and type, right? I mean, it's distracting when you're trying to teach. So if you're going to come, try to pay attention for most of it. And if you're not going to come and don't want to pay attention, then don't come. Just watch the videos on YouTube, right? And look at the notes on Canvas, right? All right, does anyone have any questions? Yeah.
Yeah, how quick are you on uploading the videos? Does it take like a day?
If I'm not too tired at the end of the night, I'll post it tonight. Otherwise, it'll be tomorrow morning. I'll try to get it after class, but sometimes I have things to do. It'll be Wednesday morning at the latest. Okay? Yeah.
Yes, can links to the YouTube videos be found on Canvas?
Yeah. Yeah, so everything, all the links will be on Canvas. There's one more thing I want to say, though, actually, that just reminded me. So before you can see these, the content, the material on Canvas, there's a little, I call it a responsibility quiz. It's an intro quiz. It doesn't count for anything, but it counts. All it does is unlock the course. Basically, it's kind of like an end user license agreement, right? When you download any software, there's a whole bunch of terms saying but no one ever reads it. But you know how to legally use the software. You go yes, 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 and then you can use the software. Same thing for my class, but it's related to the syllabus, right? Do you know policies related to the syllabus? Do you know to bring a pen to the test? So you just take that quiz. It'll be there when I upload things on YouTube. It's the first thing that you'll see. You just go yes, 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 assuming that when you click yes, you understand what you're doing. And then when you say yes to everything, it unlocks the whole course, right? And all the material. All right, so any other questions? Someone else, yeah.
The class that you have before this, is it going to be like the same exact pace? Like if we were to show
Yeah, that's another Good question. So I teach another class. I mean, it's the same class. The exact same thing. I just repeat myself for 2 hours, what I just said for 2 hours. In SO 250, from 5 to 6:50. So I guess the question is, if you wanted to go to that class instead of this class, you could do that, assuming there's seats there, which there probably will be. But that class is horrible, though. It's not as good as this class. I mean, as far as the teaching experience, it's loud and it's designed weird. I don't like it at all. This class is much better. But yeah, so you can come to that class if you want to come to that class. Although the tests, you have to take it with your section, right? Any other questions? Yeah.
On average, how long does it take to complete the homework?
It depends on the topic, but a while. That's the point of the homework, though. It's physics, and yeah, so you have to think at some point, and you think during the homework, and then hopefully that's the only time you really think. If you understand it, then the quizzes and the tests are fairly straightforward. Okay. Any other questions? Yeah.
So let's say you have a B in the class and by the time it's time for the final, could you actually get a worse grade then by taking the finals?
Yeah, if you go through the detailed explanation on the final here,
If you see so many numbers.
yeah, the upshot is you can do better or worse on the final. So you can either improve your grade or not improve your grade. So, yeah, you have to figure that out. If you know, but like I said, just try to get an A, and then there's nothing to figure out. Okay. Okay. So, are there any other questions? Yeah.
How much time do you recommend studying for this class outside?
I don't know, probably 5 to 10 hours a week. I think if you do that, you'll be pretty good. Depends on the person, though. Some people need more, some people need less. There's probably going to be either 8 or 9 of each.
Sorry?
There's probably going to be 8 or 9 of each, depending.
Well, for the studying, you say that includes SI or besides? That's what I'm marking.
I mean, you can. I mean, I guess it would include SI. I don't really know. Yeah. I haven't thought about that. But any other questions? All right. So it's 7:56. It's around 8. So why don't we take a 10-minute break? When you come back from the break, we'll start the some material. Deal. All right. So, okay, so I post these PowerPoints on Canvas as well. Let me just say that the PowerPoint's a little bit wordy, a little bit hard to read in the, during class, but that's not the point of the PowerPoints. The PowerPoints are like mini, book. It's sort of just kind of like the book. So the point is, don't try to read the PowerPoints. Just pay attention to what I'm saying. And read the PowerPoints on your own later on, right? Also, all this stuff gets posted online. Everything I write, everything is on the PowerPoint. So you don't really need to take that many notes, just notes to yourself. I suggest just paying attention instead of writing, right? Okay. So having said that, let me just say that the first thing we're going to do is do some intro stuff. We're not going to do any physics until probably Thursday, at the end of class on Thursday. So we're going to start doing a little bit of trig, because there are some people that don't know any trig, and then we're going to start talking about proportions, which will just start today. We'll finish it on Thursday. And also a little remark about unit conversions and something called dimensional analysis, which we'll do on Thursday as well. We'll spend a majority of the time for the rest of the class today talking about trig and geometry, actually. So here's a triangle. And trig is used to basically study triangles. That's what it's, the whole point of trig. So you can study triangles other than right triangles, but almost all the triangles that we talk about in physics are going to be right triangles. So we're going to focus on right triangle. So of course the right triangle has an angle which is 90 degrees. So to analyze these triangles, you can either use trigonometry or geometry. Everyone forgets about geometry. So you can use geometry, and geometry is used as well. In physics, for instance, there's the Pythagorean theorem. If you know 2 out of the 3 sides of a triangle, you can always find the third side if it's a right triangle by using the Pythagorean theorem, which I'm sure everyone knows, right? C squared is equal to A squared plus B squared. So if you know C and A, you can find B. If you know A and B, you can find C. If you know B and C, you can find A, right? Just using that equation. The other thing you can use related to just geometry is the fact that 3 angles inside a triangle add up to 180. But since one of them is 90, it means that the other 2 angles that you don't know add up to 90. Right? That's another thing. So if you know one of the 2 angles, you can find the other angle that you don't know just by that fact. They're complementary, they add up to 90. By the way, I didn't explain what these symbols are. Let me explain them now. So this thing's called a theta. It's a typical symbol for an angle. It's a horizontal line with circle with a horizontal line. Right? That's a theta. And this thing's called a phi. It's a circle with the vertical line. Right? So it's just typical symbols used to define angle. But anyway, theta and phi add up to 90, right? They're complementary. Right? For an angle. So if you know theta, you can find phi. If you know phi, you can find theta, right? Okay. So we'll do examples of this in a bit, by the way. But let me go through the theory first before we start doing examples. All right, so that's a little bit of geometry which can be used for triangles. But the other thing you can use for triangles is trigonometry. So trigonometry is useful when you don't have 2 sides and you want to find a side of a triangle, not knowing only knowing say one side, or knowing all the sides of a triangle and trying to find an angle inside there. You can't do that with geometry. You can only do that with trigonometry. So how do we do trigonometry? So there's 3 basic trigonometric functions, which are cosine, sine, and tangent. We're going to focus on those. That's basically all we use in this course is cosine, sine, and tangent. So if you can understand cosine, sine, and tangent, whether you've had trigonometry before or you haven't had it before, you can do physics, right? Otherwise, you can't do it. It's pretty hard to do without trigonometry. All right, so let's see how we do cosine. All right. So there's this function called cosine, right, of, say, x. So x can be any angle. There's 2 angles. It can be theta or phi. So x is just some angle. It doesn't have to be these 2 angles, any angle. So the cosine is defined to be the length of one side divided by the length of another side. Particularly, it's the length of the side which is adjacent to the angle divided by the length of the hypotenuse, which is c here. C is always the hypotenuse in this sketch. What's the adjacent and opposite, as you'll see for sine, depends on what angle you're talking about. So let's talk about this angle. So you can find the cosine of theta. This is theta. You can say, what's the cosine of theta? The cosine of theta is the side that's adjacent to theta. Well, what is the side adjacent to theta? Okay, so theta goes, see the 2 sides that sort of form theta are B and C, right? C is the hypotenuse, B is the adjacent side. The 2 sides which form the angle, the thing that's not the hypotenuse is the adjacent side, right? So for cosine, the adjacent side is B. So the cosine of theta is the B, the length of side B, divided by the length of the hypotenuse, which is C. So the cosine of an angle is less than 1, because C is the largest angle, largest side, I should say. Right? So you're always getting a number less than 1. But it's just that thing. You take the length of one side divided by the length of the other side. That gives you the cosine, whatever that works out to be. So cosine theta is B over C, as I've written here. So you can use this to say find side B, the length of side B, if you know C and theta. If I multiply by C on both sides, I get B is equal to C times the cosine of theta, right? So basically, if I know C and I know that angle theta, I can find the length of side B, right? You can't do that with geometry. You can only do that with trigonometry. But you could also say, what's the cosine of phi? So the cosine of phi, A and C kind of form phi, right? So side A, because side C is the hypotenuse, side A is the adjacent side to phi. So the cosine of phi, this angle here, is not B over C, it's the length of this side, which is A, divided by the length of this side, which is C. So the cosine of phi is A over C. And you can use that to find side A. So if I multiply both sides of that equation by C, I get A is equal to C cosine phi. So that gives you a way to find side A if you know phi and C. There, does everyone understand cosine? Specifically people who never had trig before. Well, we'll do some examples. Hopefully people that don't have trig understand it after that. Okay, so then one of the other functions is sine. So sine of any angle, this is just any angle, is equal to the opposite side to that angle divided by the hypotenuse. Okay, so what is it for theta, right? So I want to find the sine of theta. So the sine of theta is the side opposite of it, or the length of the side opposite of it. So what's the side opposite? It's the side that's, facing the angle here, right? So this side here is facing theta. So this is the opposite side. So the sine of theta is the length of side A divided by the length of the hypotenuse, which is side C. So this is sine of theta, it's A over C. Once again, if I multiply both sides by C, I can find side A. It's another way to find side A. The length of side A is C times the sine of theta. So if I know C and theta, I can use that to find the length of side A, which is the length of this side. You could also do it for phi. So what's the sine of phi? So the sine of phi, this angle here, is the length of the side opposite of it, which is B, right? For this case, it's B, divided by the length of the hypotenuse, which is C. So it's B over C is the sine of phi. Once again, if I multiply that by C, both sides, I get B is equal to C sine phi. And it's a way to find the length of side B if I know the hypotenuse and the angle phi. Now, one thing you can say, okay, well, I can use this equation to find A, and I can use this equation to find A. So which one is it? Well, either equation works. Where is it? Here? They're both A. So you can see that C cosine phi, which is this, is equal to C sine theta. So you get this equation here. The C's cancel out, and you get sine theta is equal to cosine of phi. So basically, if you have two angles which add up to 90 degrees, they're complementary. The sine of one angle is the cosine of the other one, and vice versa. Right? Okay. Does that make sense for sine? All right. The last one is tangent. So there's a couple ways to define tangent. This is the basic way. I'll talk about this in a second, but let's focus on this first, right? So tangent of some angle, it could be any angle, is the side opposite of it divided by the adjacent side. The length of the side opposite of it divided by the length of the adjacent side. So say for theta, right? What's the tangent of theta? It's the length of the opposite side, which is side A, divided by the length of the adjacent side, which is side B. So tangent of theta is A over B. Right? That's another way to find side A. If I multiply by B, I get A is equal to B tangent theta. It's another way to find side A. But the most common use of tangent is not to find the length of the side, although you can do that. This comes up every once in a while. It's to actually find an angle given two sides. So I know that tangent theta is A over B. So if I take what's known as the inverse tangent, there's an inverse tangent thing on your calculator. The inverse tangent of A over B is equal to theta. It's a way to actually find what theta is as an angle. It's by taking the inverse tangent of A over B. Now, if you notice, I have absolute here. So what does that mean? Okay, so mathematically speaking, when you talk about a triangle, the lengths of the sides are always positive. You can't have negative lengths. So these side A and side B, the lengths of them are always positive for normal triangles. However, when we do physics, which is sometime next week or maybe the week after, but sometime fairly soon, you'll see that some sides are negative in physics. It doesn't happen in math. But in physics, the sides can be negative. So what I'm saying here is if you have a negative side, you basically ignore the negative and just use the positive, right? But you don't worry about that for normal triangles, right? Okay. What about phi? Doing tangent for phi. So tangent for phi is the opposite side, which is length of side B. That's the side opposite of it, divided by the adjacent side, which is A. So it's tangent of phi is B over A. And you can do the same thing that we did for theta. You can find B by multiplying by a on both sides. B is a tangent phi. Or you can find the angle phi by doing the inverse tangent of b over a. Absolute value in case they're negative. Now what about this? So if I plug in sine and cosine into this equation here, so sine is opposite over hypotenuse, and then adjacent is, cosine is adjacent over hypotenuse. When you put that into this equation here, you get opposite over adjacent. So what I'm trying to say is another way to define tangent is the sine of an angle divided by the cosine of the angle. It's the same thing as opposite over adjacent. This comes up every once in a while, but for now you want to focus on this way to define tangent, right? Opposite over adjacent. So to summarize, these are the three basic trigonomic functions. These are the things you have to remember. That cosine is adjacent over hypotenuse, sine is opposite over hypotenuse, and tangent is opposite over adjacent. There's this thing, or mnemonic device you can use to remember that, SOHCAHTOA. So the first three letters stand for sine is opposite over hypotenuse. The next three letters stand for cosine is adjacent over hypotenuse. And the TOA stands for tangent is opposite over adjacent, right? So that's SOHCAHTOA. Right? All right, so now we're going to do some examples with this, right? To see if you understand what I just talked about. All right, so I got to sit down. This chair is kind of low, but none of these chairs work, so you might not see me. You can see me right, though. That's the important thing. All right, because I can't stand right. It's too awkward. I have to sit down. All right, so let's see how low this chair is. It's kind of low. Not too bad. Okay, so let me go here. So this is where we do the examples. So I type whenever I can because you can't read my handwriting. So I try to type a lot. Okay, so I'm going to grab I didn't do it. Okay, so, all right, so here's a shape I made ahead of time. So this is what I mean, just, if you have to write notes to yourself for things that are confusing, fine, but otherwise I just suggest just sit there and listen, right? Because all these notes will be printed out in a PDF and posted online anyhow, right? Okay. So we have this triangle. This is a typical right triangle. This is phi and theta, just like the PowerPoint. Suppose we're given what A is. So A is, I'm going to change that back to lowercase here in a second. Once nope, okay. So I'm just, oops, I don't want to do that. All right, did it again. You have to turn the stupid, there it is. Capitalization off. All right. I don't know why it wasn't there before. Okay. So say A is 3. Right? That doesn't come from anywhere. I just made it up. And this angle theta, I'm going to move it out a little bit so I can write here. But this angle is theta. And theta is 32. It's just some weird angle, right? It doesn't matter what it is. I'm just making up some random weird angle. So this angle is 32. 32 degrees. Okay. Well, I can't write this thing. All right. So that's the only thing that you know. You know that this side has a length of 3, and this angle is 32 degrees, right? That's it. So the first part, there's a few parts, but the first part is what's the length of side B, given what we know. Okay. So this is kind of simple. If you've seen it before, even if you haven't seen it before, it's not terribly hard. I'll show you how to figure it out. But this thing here is exactly what you do for physics when we see physics, right? So in physics, you're given some information. In this case, it's A is equal to 3 and theta is 32 degrees. But there'll be some analogous information in physics, right? And some problem. And then you're going to be asked, well, what is this? So you have to relate what you know to what you don't know. That's how math works. That's how physics works. It's the same exact thing. So what you have to do is you have to figure out, okay, what do I know in relation to, say, theta, the angle that you know, and then what don't I know, and how does that relate to theta? And then figure out something that relates what you don't know to what you do know. So let's look at theta. What is side A in relation to theta. So theta is the thing we know, right? So what I want to do is relate the other thing that we know to the thing that we know, which is theta, right? So what is side A in relation to theta? It's the opposite side, right? What is the thing we're trying to find? B. How does that relate to theta? Well, it's the adjacent side, right? So, I'll write that down. So, side A is opposite of theta, and side B is adjacent to theta. So what I'm trying to say is we know the opposite side. We're trying to find the adjacent side. So what is the only trig function which has opposite and adjacent in it? Tangent, right? So that's how we relate those two things together. And physics is done the same way, right? Except you have other equations. It's the same thing, right? Okay, so let's figure this out. So tangent, so this is why I try to type everything. Tangent theta is equal to the opposite side divided by the adjacent side, right? So in this case here, the opposite side is A, like I said, and the adjacent side is B. So it's A over B. So the tangent of 32, because theta is 32, A is 3. So you get 3 over B. And then it's just algebra. We need to solve for B. So how do you solve for B? You get B is tangent of 32 degrees is equal to 3. I just multiply by B on both sides. And then you got to solve for B by doing one more step. Sorry, 3 divided by the tangent of 32. And yeah, you just put that in your calculator. So you sort of want to make sure that you get the same answer I get, so you know how to use your calculator when it comes to trig. But you want to check that. So I should mention that, that I basically just round off to 2 decimal points most of the time. There's significant figures and things like that, but I don't really care that much about them, quite frankly. Other classes do. I don't. So I just usually round off to 2 decimal points, and that's basically how you do everything. Right? All right, so does that make sense? Okay. So let's do part B. So part B is find the length of C using the original given information only. So what I'm saying is we know what side B is now, but I'm saying suppose you don't know side B, right? And you only know side A and theta. So how would you find side C only using side A and theta? All right, so once again, go up to this picture, right? Suppose you only knew A and theta, right? And you want to find side C. So once again, how is A related to theta exactly as it was for part A? It's the what? Opposite side. What's side C? The hypotenuse, right? Okay, so I'm going to copy this. It's not the same thing. I'm going to change this slightly, but it's similar wording. All right, so side C is the hypotenuse. It's not really adjacent or anything. So we know the opposite side, and we're trying to find the hypotenuse. So what is the only trig function which has the opposite and hypotenuse in it? Sine, right? So we're going to use sine, right? That relates to 2 things. Okay, so let's do this. All right, so the sine I do occasionally write too fast and write something down wrong every once in a while. That happens. So if I write something down wrong, just let me know. It's the opposite side divided by the hypotenuse, right? That's the definition of sine. For this case, the opposite side is A, and that's C. So the sine of 32, that's supposed to be 32, is 3 over c. So if I multiply by c on both sides, I get c times the sine of 32 is equal to 3. And then I want to find c, so I divide by the sine of 32. Anyhow, that's supposed to be 32. I just can't write. So it's 5.66. So that's the length of side C, 5.66. Of course, you could have done it a different way. There's more than one way to do almost everything in math, and same in physics, as you'll see. I told you to ignore your answer for part A, the length of side B. So suppose you calculated this using side B, knowing what side A is. How would you do it? What would you use? If you knew side A and side B, and you want to find side C. The Pythagorean theorem, don't forget about that, right? This comes up in physics too, right? We use this a lot, right? So c squared is equal to a squared plus b squared. So c is equal to the square root of a squared plus b squared, of course. So I'm just going to write 3 squared plus 4.8 squared. If you take the square root of that, you get 5.66. So I'm just demonstrating there's more than one way to get the same answer, but it doesn't matter as long as you get the same answer. But why would this way be slightly worse than doing it this way, the first way we did it? Yeah, right. Both answers are right. One, this is rounding, so this makes this a little bit off. Although in the context of things we do here, I don't really care about that much. The bigger reason is because if you got A wrong, I mean part A wrong, you get the length of B wrong, then of course C is wrong, right? It compounds your mistake. So this one doesn't use things you already calculated, right? So you get a less chance of getting it wrong using this way than this way, right? Okay. All right, so let's go. Okay, so this is pretty straightforward, but it's people sometimes forget this. What is the angle of phi? What is phi? It's an angle, so you could say, what's the angle of phi? Let's say, what's the angle of phi? That's probably a better way to say that. What is the angle of phi? So you can do it using trig, but the easier way, what's the easiest way to do it? There's more than one way of doing it, but the absolute easiest way of doing it, does anyone know? Right. You got to remember the two angles add up to 90, and that comes up quite often in physics as well. So don't forget the geometry part, right? Everyone just focuses on the trig part, but the geometry part's important too. So phi is just 90 degrees minus theta. So phi is 58 degrees. Okay. You could also do it using trig, but this is the easiest way of doing it. Okay, so okay, one more part, for this problem. So find side B, the length of side B, using side A and phi. So suppose you only, side A, sorry, I forgot to write A. Suppose you know side A, which is given, and phi, which is practically given, because you just subtract 90 degrees, or subtract 30 degrees from 90, and you get phi, which is pretty easy to do. So the question is, how do you find side B just using side A and phi? Now let's go back up here. So suppose you only knew what phi was in A, and you're trying to find B. So how does side A relate to phi for this case? It's adjacent. How does side B relate to phi? Opposite, right? So what do we use again if we have something that we, that we want to use opposite and adjacent for? Tangent, right? So it's pretty similar to this, but I'm going to change the wording. Obviously, it's not the same thing. All right, side A is adjacent can't type. Some days I can't type. 2 phi. And side B is opposite, right? But regardless, we got to use tangent, right? But I just want to point out that, you know, the tangent of theta and the tangent of phi are two different things because it depends, what you call side A and side B are relative to theta and phi. So this case here, so this is B, right? B over A, right? So for tangent of theta, it was A over B, right? For tangent of phi, it's B over A, right? Because the sides are reversed. So what we get is the tangent, and we already know what this answer is, so it's a good way to check, to see if you're doing it right. This is B over 3. So if you want to find B, all we do is just multiply by 3. I was going to write it on the same line. You get the same answer. You get 4.8. You can check it yourself, right? So we found the length of side B in part A using the other angle, but you can also do it using phi. All right, so does that make sense? All right, so let's do a different example. We're going to move on to something different. So this is more relevant for physics, something like this. All right, so I'm going to copy this triangle. I'm going to change the numbers and everything. All right, so most of the time in physics, as you'll see in a week or so, we often are given the hypotenuse. So suppose we don't know side A, but we know side C. There it goes again. Let me do it now. Okay, so side C is 10. Right, we know side C. And I'm just going to change this angle. We know theta, but it's not 32, it's 42. I just changed it randomly to a different number. It doesn't really matter. But this is typical in physics. We know the hypotenuse in one of the angles, right? And the typical thing that we want to figure out is what is the lengths of the other sides, A and B, given the hypotenuse and an angle. So that's what we're going to do. So just given this information, we want to find side A. Okay, so once again, we want to relate what we know to what we don't know. So side C is the hypotenuse, right? Which is what we know. And side A is, what is it in relation to theta? Again, is opposite of theta. So once again, we have the opposite, we want to find the opposite side. We know the hypotenuse. So we want something with opposite and hypotenuse in it. So what is opposite? What is opposite and hypotenuse in it? Sine, right? So we're going to use sine, right? So I'm going to borrow this because it's pretty close to this, right? But, okay. So once again, sine of theta is opposite over hypotenuse, which is A over C, the same thing as what I wrote before. But this time I want to find side A because I know side C. So basically all I do is multiply by C. It was in the PowerPoint too. It's just C times the sine of theta. So it's 10 times the sine of 42. So the length of side A is 6.69. Right? So that's the length of side A. This is what we do a lot of in physics, right? We're given the hypotenuse, you're going to find the length of one of the sides. All right, so does that make sense? All right. I don't know if it does, because it doesn't say anything, but hopefully it does. So the next thing I want to do is find side B. Using only theta and the hypotenuse, right? So given, the initial information, right? Suppose you don't know what side A is, right? The length of side A. Okay. So forget we know side A. We could do it using side A, but let's forget that. So let's go back up here. So we want to find side B, assuming we only know what C is and theta. So how does side B relate to theta? It's the adjacent side, right? Side C is still the hypotenuse, correct? All right. So kind of similar to this, but we need to change the wording a bit. Oops. So side C is still hypotenuse, but now we want to find side B, and side B is adjacent, right, to theta. So what do we got to use? We want to use adjacent and hypotenuse. What is adjacent and hypotenuse in it? What do we use? Cosine, right? We got to use cosine. All right. So do I have cosine? No. Okay. So let me write down. This is the first time we use cosine. So cosine so it's B over C. So we want to find B. So if we want to find B, we multiply by C. C cosine theta, which is 10. It's supposed to be cosine of 42. So B works out to be 7.43. So you can find the length of side A and B if you know the hypotenuse in one of the angles, right? You could also do this using Pythagorean theorem, assuming side A is correct, but this is the better way of doing it. All right, so does that make sense? All right, we're going to go on to a third example. This is another thing that comes up all the time in physics. So the other thing that comes up all the time is we know, say, 2 of the 3 sides, and we want to find an angle inside the triangle. So we don't know this angle. I'm going to move it back to where it normally is. But we know, we don't know side C either. But we do know side A. It's got to go, oh, that worked. We know A is 3, and we know B, there it goes, is 4. So that's the only things that we know, right? Side A and side B, which comes up in physics quite often, right? We know 2 sides. So the question is, what is theta? So this angle here, this is theta, right? This one. So once again, we have to figure out what we know. Well, we know side A and side B, so how does that relate to theta, which is the thing we're trying to find. So what is side A in relation to theta? We already did this once before. It is the opposite side, right, of theta. What is side B in relation to theta? It's the adjacent. So we know the opposite, we know the adjacent, so what do we need to use to figure this out? Tangent, right? Tangent is opposite over adjacent. In fact, we already sort of did that here. Right? Tangent of theta is A over B. It's the same thing. I'll write this down. Okay, so side A is opposite of theta, and side B is adjacent to theta. So we use tan, right? And it's this, right? So side A is opposite, side B is adjacent, so tangent of theta is A over B. So the tangent of theta is 3 over 4, right? Because A is 3, B is 4. This is 0.75. That's the tangent of theta. It's not theta. So how do you find theta, the actual angle? Anyone know? Yeah, you have to take the inverse tangent. The absolute value if it's negative, but in this case it's positive because for normal triangles it's positive. Inverse tangent of that. So this works out to be 36.87. So like I said, this comes, I don't know why that keeps on happening. This comes up a lot in physics. We have two sides, we want to find an angle. So that's how you do it, right? That's one way of doing it. And of course, you can find the other angle if you know this angle. So I'm not restricting you, just how would you find phi? Any way possible. What's the easiest way of finding phi if you know theta? Yeah. So just by knowing two sides, you can find both unknown angles, right? You can use trig to find one of them and then use geometry, right, to find the other one. It's the same thing. So instead of 90 minus 32, of course, it's 90 minus 36.87. And the angle phi is 53.13. Of course, this is a little bit dangerous because if theta is wrong, then phi is wrong. But it's the easiest way to do it, right? Okay, so does that make sense? Does everyone that never had trig understand that or not? Okay. All right. So I just want to do a couple more slides, and you guys can go, right? And we'll do more examples related to the slides we're going to go over on Thursday, right? Okay, so let me go back to this thing that kept on popping up. That's not where I want to go. I want to go here. Okay, so the next thing I want to talk about is proportions. Proportions are actually fairly often used in physics, so it helps to understand just what they are mathematically, and then we'll see how we use them in the context of physics when we get to it. Okay, so this is the most simple sort of proportion you can possibly see. This equation here, y is equal to 2x, right? So basically, when you talk about proportions, what you want to do is you want to figure out what happens to y when you change x by a factor. Now, factor is often misunderstood. A factor means multiplying x by some number or dividing x by some number. It doesn't mean adding something to x or subtracting from x. Whenever you hear the term factor, it means you take x and you multiply it by something, or you take x and you divide it by something. So the question is, what happens to y if you take x and you multiply it by some number or divide it by some number? Right? So first of all, for proportions, we don't care about any number that's in front of x. So there's a 2 there, but you can get rid of the 2. It doesn't matter, right? It's just, you can think of it as y is equal to x. So the basic question here is what happens to y if x gets bigger? Does y get bigger? I mean, it's pretty obvious, right? I mean, it gets bigger. What happens to x what happens to y if x gets smaller? Gets smaller. So in this sense, we say that it's proportional to x because whatever x does, y does the same thing. If x goes up, y goes up. If x goes down, y goes down. For this case here, it's directly proportional to x. You'll see an example in the next example that we'll see where this isn't the case. But what this means is, because there's just an x here, basically, you can look at it as like y is equal to x because you can ignore the 2. So basically what happens is if x increases by a factor of 3, which means you take x multiplied by 3, the y increases by 3, right? If x triples, y triples. If you take x and multiply it by 10, y goes up by 10, right? It also increases by 10. If you take x and you divide it by 100, then y goes down by 100, right? And by down, I mean divide by 100, right? So does everyone understand that? That's pretty straightforward. Okay. A common thing that comes up all the time is there's 2 ways to say the same thing. So if I decrease by a factor, say 5 in this example, it's the same thing as multiplying by a fifth, right? Decreasing by 5 is the same thing as 1 over 5. So you can say, what if I take x and multiply it by a fifth is one way to say it, or you could say, what if I take x and divide it by a factor of 5? Right? It's the same way. 2 different ways to say the same thing that people often get confused about. All right, so let's do a more complicated case of proportions. All right, so here's y is equal to 1/3 x squared. So once again, you ignore the 1/3. You don't really worry about it. This could be a million. It could be negative 1,000. It could be 0.000001. It doesn't matter. Right? You ignore any number here. What you're focusing on is the x squared and where it is, right? So it's basically right next to the y. Y is equal to something times x squared. So the basic idea is if you make x bigger, what happens to y? Does it get bigger or smaller? It gets bigger, right? What if you make x smaller? Does y get bigger or smaller? It gets smaller. So in this sense, we say that it's still proportional to x, right? Still proportional, I should say. But it's not proportional to x. It's proportional to x squared because this is x squared. It's not x. It's x squared, right? There's a square there. So what that means is if you increase x by some factor, then y goes up by that factor squared. If you decrease x by some factor, then y goes down by that factor squared. So if you take x, there are some examples here. Let's do different examples. Suppose you take x and you increase it by 6, right? You multiply it by a factor of 6. What do you think would happen to y? You take x and you multiply it by 6. What happens to y? 6 squared, right? 6 squared. It'd be 36. It'd be 36 times larger than originally was, right? What if I took x and divided it by 7? So I take x and divide it by 7. What happens to y? Anyone? No, not the square root. 7 squared. So if you take x and you divide it by 7, which is decreasing by a factor of 7, y would decrease by a factor of 49, right? 7 squared, 49. That make sense? Like I said, we'll do some examples on Thursday. But, okay, so here's an example that's not like the others, right? So here is y is equal to 4 divided by x. So of course the main difference here is x is in the denominator, right, of a fraction. So once again, you ignore the 4. This could be negative 10, a billion, doesn't matter. You ignore that, right? So, but the point is the x is in the bottom, right? So basically, if x gets bigger, you're dividing by a bigger number. What happens to y? It gets smaller, right? Because you're dividing by a bigger number. And the converse is true. So if x gets smaller, what happens to y? So if x gets smaller, what happens to y? It gets bigger, right? They do inverse things. If one gets bigger, the other gets smaller, right? So we say it's inversely proportional, right? If you have an x or something in the bottom. In this case here, it's inversely proportional to x because it's just x. It's not x squared. We'll see an example of that later. So what that means is whatever you do to x, y does the exact opposite, right? So basically, if x goes down by 5, y goes up by 5. If x goes up by 6, I forget what I just said. But if they go opposite, right? If x goes up by 6, y goes down by 6. Does that make sense? Let's do one more, and then you guys can go. So here's an example slightly more complicated. Once again, you ignore the number here. But you have an x cubed in the denominator, right? So anytime you have something in the denominator, that's inversely proportional. But this time it's inversely proportional to x cubed, because it's x cubed. It's not x, it's x cubed. So that means that, once again, they do opposite things. If x gets smaller, y gets bigger. X gets bigger, y gets smaller. But it changes by the factor cubed, because it's x cubed, right? So I have some examples here, but let's make up different examples. 4. All right, suppose you take x, right, and you make it 4 times bigger. You multiply by a factor of 4, right? What happens to y? Right, it goes down by 4 cubed, which is 4 times 1, it's 64, right? So it goes down by 64. So what if you take, so what if you take, what did I just do? Increase? I just did increase, right? So what if you decrease x by 6? A factor of 6. Take x divided by 6. And then y goes up by 6 cubed, right? Because it's cubed. Whatever that is. don't know, 60, 36, whatever it is, right? Okay, so anyhow, we'll do some examples on Thursday. We'll also do more complicated examples on Thursday, as you'll see. But we'll do some examples on Thursday. So see you on Thursday.